Today we're going to be learning about exponential growth and decay. So our learning target is how can I write an equation to model exponential growth and decay. Vocabulary, an exponential function. This is a new type of function. You guys have been working with linear functions, which have been lines. Now we're going to work with exponential functions. It is a function in the form y equals a times b to the power of x. Now there are some specifications. A cannot equal 0, b needs to be greater than 0, and it cannot equal 1. The pieces of the exponential function are as such. Y equals a is going to be your y-intercept. So if you want to make a little note there for a, that's your y-intercept. We could compare that to y equals mx plus b, our linear model, where b is the y-intercept. That a piece is the y-intercept, where we cross the y-axis. The x is the power. It's your exponent. It makes it an exponential function. And the b is your base. And it controls whether it's growth or decay. So b would be like your slope. It's going to represent your change. And it's going to be a growth function if it's a whole number. It's going to be a decay function if it's a fraction. So a is your y-intercept and b is your change, and it controls whether it's a growth function or a decay function. All right, let's compare a linear function to an exponential function. Linear function, we have y equals mx plus b. M is your slope, it's your change. So we look at our change in our x values versus our change in our y values. Our x values are going up by 1, and our y values are going up by 3. So we would write our slope as 3 over 1, which would just be 3. So y equals 3x, because I know my m is 3. Now I just need to find my b. B is the y-intercept, and that's where x equals 0. So we would add 4 to our equation for the b. Exponential function is fairly similar. We look at our x values, they're changing by 1. We always want our x values to be changing by 1 in an exponential function. Then we want to look at our y values. We want to look at how do we get from 2/3 to 2? How can we get from 2 to 6? 6 to 8, and it be the same each time. Now, if we look from 2 to 6 and 6 to 18, we can't add the same number because 2 plus 4 would give us 6, but 6 plus 4 doesn't give us 18. So we're going to have to look at multiplication. 2 times 3 is 6. 6 times 3 is 18. 2 over 3 times 3 equals 2. 2 over 3 times 3 over 1 is 6 over 3, which equals 2. So that's one of the main differences. This change is going to be multiplication. However, your change, that's your b. So our b is 3. Our y-intercept, still where x equals 0. However, we're just representing it with a different letter, letter a. So you would say a equals 2 and b equals 3. Write out your equation. Y equals a times b to the power of x. So we would substitute in a is 2 times b is 3 to the power of x. Let's practice that some more, writing rules or equations from tables. So we want to write a rule for each of these from the table. First, check, is your x changing by 1? Yes, it is. So we're good on our x values. Now we have to find our change in our y values. Remember, you're looking for multiplication. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. That value right there that you're multiplying by, that's your b. b equals 2. Find your a, your y-intercept where x equals 0. That's going to be our a. So a equals 8. b equals 2. Now we just need to write our equation. Remember, our equation form is y equals a times b to the power of x. So we say y equals a, which is 8, times b, which is 2, to the power of x. Now, if we look at this, our y values, they're growing. They're getting exponentially bigger as we go down the table. We call this an exponential growth function. As your x values get bigger, your y values get bigger. Now let's look at our second equation. Check your x values, make sure they add up by 1, which they do. Second, we need to look at our y values. First off, there is a small typo. We want to change that 8 to a 16. Now we want to look at how are our x values changing. Again, we want to look at multiplication. Now, if we think about it, 16 divided by 4 would give us 4. 4 divided by 4 would give us 1. 1 divided by 4 would give us 1/4. However, we don't want to write it as division. We do want to write it as multiplication. So to write dividing by 4 as multiplication, we write it as times 1/4. So that right there, times 1/4, that's our b, 1/4. Next thing we need is our a, our y-intercept, which is right here at x equals 0. So we say a equals 1 and b equals 1/4. Write out your exponential equation. We have y equals a, 1, times b, 1/4, raised to the power of x. Now, if we look at this table and our y values are getting exponentially smaller as our x values get bigger, we call this an exponential decay function. Now, if you look, exponential decay, we talked about that at the beginning in vocabulary. The b is a fraction. Exponential growth, the b is a whole number. All right, last piece is graphing exponential functions. So we're given our function. We want to make a table. So let's draw a table. X, y. We're going to use -1, 0, 1, and 2 for our x values. Plug those into our function. Y equals 2 to the power of x. We're putting those numbers in for x. Y equals 2 to the power of -1. Y equals 2 to the power of 0. Y equals 2 to the power of 1. Y equals 2 to the power of 2. Now we want to evaluate those. Y equals 2 to the power of -1. Remember that negative exponent flips it around into a fraction, becomes 1/2 to the positive 1. 2 to the positive 1 is 2, so we get 1/2, 1/2. 2 to the power of 0 is 1. Anything to the 0 power is 1. 2 to the power of 1 is 2, and 2 squared is 4. Now we have nice coordinate points that we can plot on our graph. We start off with x is -1, y is 1/2. Go over to -1 on our x-axis. 1/2 is right in between 0 and 1. Next point would be 0, 1. So we have 0, 1. That's our y-intercept right here on our graph. Next point is 1, 2. We plot that point. And the last point is 2, 4. So we plot 2, 4. Now if we look, this is not making a straight line. It's making this nice curve here. We're getting exponentially larger. One piece to point out is that this bottom piece of our graph will not touch the x-axis. It will stay above the x-axis. Second equation to graph, we have y equals 2 times 1/3 to the power of x. Again, we want to make a table, x, y. Use -1, 0, 1, and 2. Set up our equations. Y equals 2 times 1/3 to the power of -1. Y equals 2 times 1/3 to the power of 0. Y equals 2 times 1/3 to the power of 1. Y equals 2 times 1/3 to the power of 2. All I did there was insert my values for x into the exponent spot, because that is what x is. X is your exponent. Now we want to evaluate these. For these, I'm going to show you how to use your calculator to evaluate. Here I have my graphing calculator. This calculator is available to you on your Schoology page. It's the MCA calculator. So for our first equation, y equals, we put 2 times 1/3. We're going to put parentheses around that. Alpha, we're going to press that y equals button and our fraction menu comes up. So we get our fraction 1/3. Go over, close the parentheses, raise it to the power, that caret above the division sign, taken to the negative first power. We press enter and we get our first answer, which is 6. All right, next one, we have 2 times, we do the same thing. We do 1/3, 1/3, raised to the 0 power. That's 2. I'm going to write these down for us. We have this first one was equal to 6. The second one was equal to 2. All right, so now we can do the last two. We can do 2 times, get our fraction there, 1/3. And we're raising that to the first power. Now this time I didn't use parentheses, but see how it added those parentheses in? So it works either way. You don't always have to use the parentheses. And then the last one, 2 times, put 1/3 in there. Raise that to the second power, and we get 2 to the 9th power. So our x value of 1 is 2/3, and our x value of 2 gives us 2/9. Now again, all we have to do is plot our points. So we have -1, 6, plot that right there. 0, 2, that's our y-intercept right there, 0, 2. 1, 2/3, plot that point. You have to kind of guesstimate where 2/3 is, and that's okay, just as long as it's right about there. It's above half, but it's not quite at 1. And then the last one is 2 and 2/9. We go over to 2, estimate where 2/9 is. Connect your points, and we have a nice curved line. It's our exponential decay. We had a fraction for our b, so this is what a decay function looks like, and this would be what a growth function looks like. That's all the notes I have for you today. Thank you for watching, and please subscribe to my YouTube channel.